I'm here to give a bit of an update on what's been happening in Swarm. So you might know we launched first alpha, very alpha test client together with Geth 1.5 last November. We published a blog post saying here it's out, let's try it out. So that was our proof of concept release 0.2. It had the basic networking layer, moving chunks around for delivery, retrieval of data, just the basics. We also set out to write good documentation so that, to make it easier for you to join in. And this was a community effort, so a lot of people helped on this documentation, and thank you for anyone out there who joined in. So with this documentation in hand and the alpha client, we could now ask finally for some community public participation. And anyone who writes software knows that first contact with the public is a scary time. So, well, how did that go? So in general, first thing is, a lot of you guys joined in. So that was really great. We had a lot of interest on Twitter, on Reddit, on our Gitter channels. A lot of activity on the on the network. We had a cluster running of a bunch of Swarm nodes on the Azure cloud. And so I'm going to give you a bunch of statistics on the network. And I would preface that saying, we cannot know the full size of the swarm. We cannot know how many requests there were because it's completely decentralized. But because we were running this cluster, we had a good estimate of what the network was doing overall. And I'll get back to monitoring the network later because that's an interesting topic for us. So the Swarm landing page is what you get redirected to when you go to our public gateway. It's a website with our orange papers, link to talks and resources. And that was requested over 10,000 times on our gateway. Now, of course, anyone who loaded it on their local swarm, we would not be able to count that. All we could do was look at the logs on the public gateway, and at some point we stopped logging because we were only using the logs to debug anyway. But that's a testament to the interest we had. Other than that, well, 2,500 unique addresses. Could be the same people over and over. Every time you start with a new data and key, you get a new address, but that's sort of an idea. 130 simultaneous nodes was the absolute maximum that we saw connected to us. Caveat, half of that was us, but still, that was pretty good, the biggest we had. 200 gigabytes of data amassed. And yeah, 1,400 hits in a single weekend for our demo video. So we got a lot of interest. So this was all very encouraging. On the cluster side, so on Azure, we had between 35 and 50 Swarm nodes running on a cluster, and they were configured in such a way that collectively they were serving the Swarm gateway, the public gateway's website, but individually they were fully fledged members of the peer-to-peer network. And this allowed us to see, for the first time, sort of how nodes interact in the network, rather than just how individual nodes act. And it worked well some days, not so well other days. We learned a lot about problems of this data distribution throughout this network. So there are a whole bunch of issues. Again, the community reported bugs, reported issues, and helped out fixing them, which was really nice. 64 issues since the launch, 30 have already been fixed, and a bunch of new contributors and a lot of new activity. So that's been really great and really heartening to see. So much for our launch. What's on Swarm right now? There are a bunch of apps already running on Swarm. On the one hand, there's the apps that we launched ourselves, the demo apps, the Explorer, the photo album. This, by the way, is the Swarm photo album app that I'm using right now for our slides. And there were other apps that just appeared that somebody pointed us to on Twitter or Reddit saying, oh, did you see somebody launched, some app? And we're like, oh, this is great. So this is the Swarm Explorer. It is one of our demos. You can load any Swarm asset and it'll render it as if it were a file explorer, and you can, browse your virtual website in just as if it were a file, like on a standard file system. This one was an interesting one. It's a really old school bulletin board system that I was made aware of last month, which uses Swarm to store the messages and Ropst and Ether to do tipping and all that stuff. So that's been fun to play with. Third one I have a screenshot of is an app that tracks ENS auctions. And this one was interesting in that it used Swarm, Whisper, and the blockchain all together in a fully decentralized little app. Also, Nick Johnson scanned the ENS registry for me. There were 46 ENS records that also registered Swarm content. Right. So what's coming next? I'm happy to announce we're almost ready with a Fuse implementation, so we could actually mount Swarm assets in a file system and interact with it with normal file system tools. The Mist team has Swarm capability in the Mist browser, and there's a Mist wallet running entirely on Swarm, and Web3.js also coming with Swarm support. Our roadmap is up on GitHub, showing when, for our next release, we'll have the first incentive layer on by default. Networks being rewritten. I'll get into that a little more later. And I believe I have a screenshot. Yes, this is the Mist browser running the Mist wallet off of Swarm in its entirety. So you can see the BZZ address at the top. That's the giveaway. So what's next for us? So the main question we always get asked is, when do we get to try the incentive layer? So the first part of the incentive layer is coming in our next release. That would be Swap. And on the development side, so one of the first things we noticed is that the networking we were writing, that is delivering chunks of data on Swarm and distributing them, was actually a far more generic piece of software. This routing could be used for much more than just Swarm content delivery. It can be used for communication. It could be used for communication in things like payment channels, or it could be used for broadcasts communications or peer-to-peer communications. And so this is being abstracted out into its own packet that could be used by other projects. And indeed, there's talk about using it with Status to route messages, or with Raiden to route their messages, because it's a directed way of routing messages on dev P2P between specific Swarm, specific nodes on the Ethereum network for whatever data you want. So that's part of this network layer rewrite point. The next aspect, and I'm going to get into this one a lot more, is a network simulation suite. We're writing a suite where we can test how our clients work in a network. Because it's one thing to know how your node works, and it's quite another to know how 30 of them will actually interact. And then with that network simulation suite, we've got a whole bunch of, there's a visualization project to see, well, how to interact or how to keep track of what's going on in the network. So let me get into this network simulation. What we want to be able to do is simulate a complex network of 3,500, 200 nodes and see how they work. We want to be able to see how routing works in our network. You know, we know what the rules are for any one node, but we want to see how the network behaves. And that could be for things like Swarm-specific ones, the litigation for lost data in the swear and swindle. It could be just broadcast messages. Anything you might want that requires many nodes to interact, you want to be able to test that. And that's more than just testing a single node. So that's why we have a network testing framework. What it allows us to do is the following. We can record a state for every node, set it up, and then we can connect the nodes, and we can play these journals, which are instructions for the nodes what to do. Things like, come online, connect to this node, or also send this type of message, ignore this request, send that request, all these kind of things. The general idea is the snapshots set up the initial conditions. The journals, they drive these simulations forward, telling nodes what to do. And at any time, you can save the state of the network as a new snapshot, and or record what's happening as a journal. And you can run this on your own computer in the in-process adapter, we call it. So you run a little simulation, try things out. And then when you're happy with the way things work, you can actually run the exact same simulation on a remote cluster using real nodes. So it's completely independent of whatever network you're using underneath. So these scenarios are portable. And the last point I want to make is that it's interactive. You can add instructions on the fly. So what can we do with this? The important thing is we can test the protocol. We can set up a bunch of nodes and make a test where we say we're sending a swarm data retrieval request, and you're expecting it to get forwarded from node to node to node, and you can expect the data to come back. So you can write this kind of trigger expect test, which allows you to write, the keyword here is protocol unit test, and benchmarking nodes. One thing to know how long a swarm node takes to deliver a chunk, it's quite another to know how long the entire swarm needs to assemble a file. So with these tools, we could actually measure that directly. And yes, dynamically, we can set up our test environment and just sort of prod the nodes, add little instructions to them, and play around with it in sandbox mode, see how it reacts. Which brings me to the last point, which is monitoring. How do you keep track of what's going on in your simulation? How do you get an overview? And how do you, or later, how do we get an overview of what's happening in the swarm in the wild? And we have a team at the Orange Lounge working on this exact problem, visualizing. So this network testing framework's also being integrated into, I have a little demo to show you. And that's over here. So they just sent me this. This is this arrived just like half an hour ago on Swarm. It's a little demo of the connection information being read out from our test. This is just a little ring of connections, but this would be, we plugged in, the nodes are reporting their connection information. It's being rendered here so we can see what's going on. And this is extensible, so all the nodes show up, can send their statistics on swap, what their swap balances are. The connections between the nodes will also be able to show us what the imbalance is, what the latencies are. And you can click on individual nodes and give them instructions. You can tell them to disconnect. You can tell two nodes to connect. And you can actually really play around with a network and then you learn about the emergent behavior. And that's really important for these big distributed systems for proof of custody, litigation, for the erasure code scan and repair, which doesn't require one node to act, but requires about 50 nodes to interact. This will be our framework where we keep track of what's going on, have the overview, and sort of really drive the development forward, hopefully. So that's what's new in Swarm. And with that, if there's a minute left, I'll take a question. Yes. Well, there's a lot of overlap with Swarm and IPFS. For us, the main. So I always like to focus mainly on the incentive layer in Swarm and how tightly integrated it is with this Ethereum. We do have a bit of a different model of how the data gets distributed, how it gets paid for. What is generally different for us is the insurance for long-term storage, which is going to be coming in proof of concept 0.4, where we want to be able to allow for the upload and disappear. As we called it, you save your data to Swarm and then you go away and your dApp will keep running and the data will still be there. You don't need to run a node, you don't need to run a server, you're completely out of the loop. If the data gets lost, other people can take up the litigation, and it really takes out the original submitter from the equation. They're no longer hosting, they're not special in any way. But there's a lot of overlap, and the teams are in contact. So, especially in terms of interoperability wherever we can. Certainly, it's not. The chunks directly are not, no. Release date of POC 3, I don't want to speculate. I want to say that the swap incentive structure is already available. It's already finished. It's just not on by default. So if you already want to play around with that on your own, you can do that with our proof of concept 0.2. But this network testing is what we've been working on mostly, and that's been making a lot of strides. And indeed, this video was rendered this morning during the first talk and sent to me on Swarm, and that worked. So that should tell you something. Well, I think with that, thank you very much.